Welcome to this tutorial on the speed of sound. It is useful for us to understand how sound travels through different mediums, such as the air and solid objects like walls. For example, we may wish to estimate the differing phase relationships between microphones placed at different distances from a source, or the effectiveness of soundproofing materials. Sound waves travel at different speeds through gases, liquids and solids. This is because their molecules are spaced differently. For example, air molecules are much further apart than the tightly compacted molecules of steel. The closer the molecules are, the less distance they have to travel or vibrate to transmit energy to one another, and the faster the sound wave can travel. Sound travels relatively slowly through air at around 340 meters per second, which is approximately equivalent to 1 foot per millisecond. Although not essential for sound recording purposes, it should also be understood that the speed of sound is affected by altitude and temperature. Sound travels much faster through solid objects. Through steel, it travels at approximately 5,100 meters per second. It is important to understand that whilst sound travels faster through solid objects, its energy is absorbed faster than in a gas or a liquid. It will therefore be either partially or completely absorbed. The amount of absorption will depend on the nature and size of the object and the frequency of the sound wave. Once converted into an analog electrical, digital electrical or digital optical signal, sound travels much faster. The speed of an electrical sound wave signal is approximately 200,000 kilometers per second. It is therefore possible to accelerate the speed with which a sound wave is transmitted from one location to another. Let's consider the example of a drummer recording in a studio. Assuming their ears are approximately 2.5 feet from their snare drum, sound will take approximately 2 milliseconds to reach their ears. But if the drum is close-mic'd and the drummer is using headphones to monitor the sound via a microphone preamplifier and headphone amplifier, the sound will be heard much sooner with a delay of only 12 microseconds. Some simple equations relate the speed of sound to frequency and wavelength. Speed of sound equals wavelength times frequency. Frequency equals speed of sound divided by wavelength. And wavelength equals speed of sound divided by frequency. The script for this tutorial can be found at our website, projectstudiohandbook.com. And finally, don't forget to subscribe at our website or Facebook or Twitter channel in order to receive notification of new videos, blog posts and member-only extras. Thanks very much for watching.